and welcome to the Connection of the Month, the series where we take you inside the HSS Connections Hub. I'm Jason McNeil, engineer with Atlas Tube, and this month we're going to be looking at the HSS Base Plate Calculator. This is a great one to review because base plates show up in almost every design that involves steel, buildings, industrial, whatever it might be. So we'll look at our calculator today, which works for rectangular HSS and round HSS columns as well. This calculator checks base plates, the anchor, as well as the concrete that's associated with the connection. In terms of concrete, it'll be similar to how other calculators on the market analyze this, in that they use plain concrete when looking at the checks. So it'll look at concrete pullout, breakout, and pryout. And if you have issues or failing with any of those, we can always turn off those checks and perform a side check if we need to go further with the anchor reinforcement. So one last thing before we get into it is I want to highlight the force transfer equations for HSS have a slight tweak compared to when we look at those for wide flange. So for wide flange, we usually assume when we're talking about M and N that we're using a 0.95 and a 0.8. So when we look at those for HSS, we get a slightly optimized equation in that we can use 0.95 for each direction, and then for round we use 0.8. Last thing is the dimension lambda n prime doesn't apply for HSS, so we can just forget that one for now. So with that, let's get into a specific calculation. Now that we're in the hub, we can select the HSS steel base plate option. We'll create our new calculation. We can come up here and name it whatever we'd like. We can call this base plate 1. And first thing, we'll come in and select our HSS size. Today we're going to be working with an HSS 18 by 6 by 1/2. We can set an initial base plate thickness. Let's try 3/4 of an inch. We'll leave our yield strength at 36, although note that you can also change this easily to 50 if you're using 50 KSI plate. We'll set our concrete as 4,000 PSI. Next options we have are in terms of setting our base plate length, width, and then associated concrete pedestal or whatever it might be there. So for our base plate, I'm just going to match what our estimated minimum plate length should be. So we can leave these as 22 and 10 for our base plate, and then let's assume 36 inches for our concrete pedestal, and then 24 in the other direction there. So you can see on the right, it's updated with my exact geometry. The outer line is going to be my concrete. The middle one here is our base plate, and then central is the HSS. So that's all looking good. We'll keep moving through. Now we're on to our anchor rod properties. It's asking if we want to include our anchor rod concrete pullout, breakout, and pryout checks. For now, let's leave that on and see how those checks are looking. We'll select F1554 rod. You can input custom anchor rods if that's your desire. For now, we'll keep it simple. You can work with a grade 55 rod and leave it as 3/4 for now. We'll stick with a standard straight rod, and let's set our edge distance as 1.5 and our embedment depth as 12. So now we have a few more options in terms of concrete. We'll set our cover as 3. Do we want to include friction capacity in our checks? For now, we'll just say no on that one. Do we want to consider grout? We will assume we have a grout pad and leave it at the 6,000 compressive strength, and then we will assume that we have cracked concrete at service loads. So then last step, all we have to do is put in our factored loads. We'll come in here and input. We have 15 shear, we have 80 axial, and then we have a moment in one direction of 60 feet. So this was all input for my X direction. And my Y, for now, I'm just going to assume that we have no loading in that direction to keep things simple. So from there, already I can see at the top that we're having some issues in terms of capacities. So our bending strength of our plate is failing, along with our shear strength of our anchors. So let's dig into a couple of these really quick. All I have to do is scroll down to the bottom and you can see all the info that's associated with the calculations here. So one important thing to notice is the base plate properties. Like I mentioned previously, here we can come in and see our M and N that were calculated. And as we mentioned, since we have a rectangular HSS, we're using this 0.95 value in each of these scenarios. If this was a round HSS, we'd be using the 0.8 value. So one of our issues was with our concrete shear breakout strength. We're at 100%, 117% of capacity. So for that, I'm going to use anchor reinforcement and not use these calculations anymore. So for now, let's turn off our checks here. And now we're no longer checking that, and we can assume that there will be anchor reinforcement provided. Next, we'll look at the bending strength of the plate. So let's try to bump that up. We're just not quite making it at 100%, 107%. So let's go up to 1 inch plate. And now everything is looking okay. Our capacities are sufficient and our base plate is designed. So fairly simple and straightforward, quick to do, and you can analyze your base plate with HSS. So that's all I have for you today. Go check it out and explore, and if you have any recommendations on this one, definitely reach out. We're always happy to hear those. Have a great day.